Why does Istanbul feel like a living bridge between eras? Beneath its mosaics and minarets is an engineering story so bold it rewrote architectural rules. This city mixes Byzantine daring with Ottoman showmanship, chaotic bazaars, quiet courtyards, and domes that float above crowds like giant, lead-clad lilies. Today we're peeling back the layers. From Hagia Sophia's gargantuan dome to the market maze that powered trade for centuries. Get ready to hear the creaks, feel the stone, and discover why these structures still stand. From the city's skyline to its spiritual heart, let's see how a half-millennia-old dome solved a square problem with pure genius. The Hagia Sophia answers one of the oldest architectural riddles. How do you place a round dome on a square base? The builders solved it with pendentives, these curved triangular surfaces that funnel the dome's weight down into 4 colossal piers. Picture a 31-meter wide dome sitting about 56 meters above the floor, pierced by 40 windows that make the roof feel like it floats. That weight, hundreds of thousands of tons of stone and brick, is carried down through a raft-like foundation 7 meters deep, so the building doesn't sag on Istanbul's soft soil. Engineers also used semi-domes and buttresses to catch the lateral thrust. After centuries of earthquakes, they added reinforcements, but the original trick, transferring dome loads into piers, is still dazzling. Walk inside and you don't just see marble and mosaics. You feel the tension between sky and stone. If Hagia Sophia was a structural breakthrough, this mosque borrowed the showmanship and multiplied it. Let's examine why. The Blue Mosque looks like a cloud of domes, but that visual is also structural strategy. Instead of one giant dome, the architect used a cascade of domes, a 23-meter central dome flanked by large and small semi-domes, to spread loads gradually toward the ground. At about 43 meters high, the main dome's weight is shepherded through pendentives and solid elephant foot piers about 5 meters across, which act like tree trunks holding a layered canopy. Inside, more than 20,000 Iznik tiles soften the acoustics and visually stitch the vaults together, while lead sheathing and careful stone masonry protect against weather. The minarets, soaring to roughly 64 meters, frame the skyline but also act as vertical counterpoints to the dome's horizontal thrust. It's a structural choreography. Beauty working as engineering, so worshippers experience calm under a carefully balanced canopy. From places of worship to imperial power, now step into a palace designed like a fortified mini-city. Topkapi Palace is less a single building and more a stitched-together defensive landscape. Courtyards, gates and walls acting like mechanical parts in a large machine. Spread across roughly 700,000 square meters, its sequence of 4 courtyards funnels visitors while protecting the Sultan's private world behind thick stone walls 1 to 2 meters wide. The Justice Tower rises to about 42 meters as both lookout and symbol. Arcades with timber trusses and lead-clad domes top ceremonial chambers. Structurally, the palace uses vaulted stone rooms and timber roofs to balance heavy zones and flexible living quarters, while iron ties and buttresses in later additions improved seismic performance. Its engineering is pragmatic. Create layered defenses that double as climate control and crowd management. If you're enjoying this journey, don't forget to like the video and subscribe to our channel for more city deep dives. From sprawling courts to a single vertical sentinel, meet the medieval tower built to see and survive everything. Galata Tower is a lesson in doing more with less. A thick, cylindrical stone column that resists wind and quake by sheer mass and geometry. At about 67 meters tall with walls nearly 4 meters thick at the base, it's essentially a stacked series of load-bearing rings. The conical roof and timber structures above transfer gravity straight down into a deep foundation system, piles and a raft footing, so the tower sits stable on uneven ground. Inside, a spiral core of stairs channels circulation, while iron ties and bracing added in later centuries knit the stone together for seismic resilience. From the observation deck, you feel how the tower's compact form slices wind rather than catching it. Its narrow top diameter reduces bending forces. Built in the 14th century and renovated many times, Galata stands because medieval masons understood geometry, not just stone. Finally, step under the city, a covered maze where markets and structure become one, and each shop relies on centuries of trickery. The Grand Bazaar is a city under a roof. A network of 61 covered streets, over 4,000 shops, and vaults that channel loads through 1,000 tiny domes. Think of it like a honeycomb where each vaulted bay passes weight down into piers and buttresses, and iron ties stitch the system together. The bazaar's double-shell domes span dozens of meters, some near 45-50 meters, and lead roofing and timber beams handle weather while letting traders pack goods below. This dense structural web also controls light and sound. Narrow alleys soften winds and create microclimates that keep pedestrians cool. Rebuilding after fires and earthquakes, layered restoration methods, stone, brick, iron reinforcements, so today you're walking through a palimpsest of techniques. It's not just a market, it's an urban machine built to move people, goods, and stresses across centuries. Istanbul's identity isn't one era or one empire. It's a conversation between structural daring and everyday life. Domes that float, towers that watch, bazaars that breathe. These buildings survived because their makers taught stone to behave like wood and masonry to bend without breaking. Which of these engineering secrets surprised you most, and which city should we tear open next? Tell us in the comments, and if you loved this deep dive, share it with a friend who loves architecture.